Hi everyone. I want you to close your eyes and imagine you're in an onshore operations control centre with responsibility for platform reliability and production. A predictive maintenance system alerts you to the probable failure of a dry gas seal in your main gas compression system. You now have 48 hours before the predicted seal failure occurs, which could lead to a plant trip and, in the worst case, many weeks of downtime and millions of dollars of lost production. The clock is ticking. What do you do? Now, predictive maintenance technology has the potential to significantly increase production recovery, reduce your operations and maintenance costs, and cut your CO2 emissions. But predictive maintenance technology can only deliver on this promise if your equipment experts use the technology to support their decisions. And they will only use the technology when they trust it. Now, we have implemented cloud-based predictive maintenance solutions on oil and gas platforms, offshore wind turbines, and are now working on solutions for mobile plant and equipment and large construction sites. And there are 5 lessons on user adoption that we have learned from these industries that apply to any predictive maintenance implementation. I want to share these lessons with you today because no matter how complete your digital twin is or how accurate your predictive models are, nothing matters unless your users trust in the predictions and then act on them to prevent downtime. Lesson 1 is about communication and collaboration. Bring the users with you by communicating clearly, consistently, and constantly. So, before you begin an implementation, you should consider who is the executive sponsor, who is the operational sponsor, what are the objectives of introducing predictive maintenance, what does success look like, and how will it change the lives of your onshore and offshore engineers. Take this information into your kick-off meeting with your implementation partner and you will get your project off to a great start. Now, during the setup phase of your project, you will need your equipment experts to participate in a series of workshops. Your experts are the only people that can provide the context to the raw data in your digital twin. And with your partner, your experts will use that data to label good and bad performance and provide input to develop expert rules. So the success of any predictive maintenance project is based on great collaboration with your equipment experts. Now, once you have your first wave of predictive models in place, you should evaluate their performance against the success criteria you set out at the beginning of the project. Share this information with your users and sponsors and use it to improve performance before moving on to run predictive maintenance on the next wave of your plant and equipment. Keep the communication clear and consistent, and you'll have the bedrock of a great project. Lesson 2 is to educate your team in artificial intelligence and machine learning. Predictive maintenance is underpinned by mathematics, and engineering teams appreciate the opportunity to understand how predictive models are created and what their strengths and weaknesses are. And operators need well-informed digital citizens to cut through the hype. Your engineers should know enough about artificial intelligence to get the best from the technology. And that's why we've partnered with Strathclyde University's Industrial Informatics team to deliver a 3-hour course on AI and machine learning designed for equipment engineers. Now, this course covers an explanation of the different types of AI and machine learning available. We then walk through the data science pipeline that is used for building predictive models. We investigate the different types of models that can be applied to predictive maintenance. And we conclude with a predictive maintenance case study from the oil and gas industry. Now, the feedback on the course has been excellent, and it provides a great primer to help your teams get the most from a predictive maintenance solution. Lesson 3 is to try before you buy. Just as you wouldn't buy a house without first having a good look around, we don't believe you should invest in predictive maintenance technology without trying it out first. That's why we recommend a short, focused pilot to let your users get hands-on with the tools and the technology. A pilot will also allow your executive team to test and measure the expected benefits before making any investment decisions. And we have a 7-step plan for running a predictive maintenance pilot. Step 1 is to agree the success criteria for the pilot, and then select a technology partner with expertise in predictive maintenance solutions. Step 2 is to choose a subset of your plant and equipment on a platform. It could be a gas compression system, for example. Step 3 is to then choose a subset of the fault modes that contribute the most to your equipment downtime. The next step is to import your telematics history, your computerized maintenance records, and your production loss records for the plant and equipment that is in scope. Your partner will then use this data to build a digital twin of that piece of equipment. You then run a series of workshops with your experts and your technology partners' data scientists to review and label historical faults. And at this point, your partner will have all the information they need to implement the first wave of predictive models to support a pilot. Once the pilot is run and complete, you can then gather user feedback and compare the actual results of the predictive models against your success criteria. And at this point, you should have all the data you need to make a go, no-go decision on moving to production. So how long will it take to run a pilot, and how much will it cost? Well, we can complete a pilot using our 7-step model in 12 weeks or less. So what about the costs? Well, there are 3 costs to consider when running a predictive maintenance pilot. The first is the cost of the time spent by your experts in the pilot workshops and the time it takes for your executive team to evaluate the solution. You also have to factor in the cost of your executive sponsor in agreeing the success criteria as well. The second cost is the cost of licensing the predictive maintenance software for the duration of the pilot. A good partner, we believe, would waive that cost. And the third is the professional services cost for the technology partner to run the pilot and configure the solution. And we believe so strongly in our pilot approach, we offer the technology for free in order to keep your operator spend to a minimum. So in the space of 3 months, you can complete a comprehensive pilot that will build user and executive trust in the use of predictive maintenance on one of your platforms. And you can use the data from this pilot to make better decisions on if and how you should roll out the technology. Lesson 4 is to start with expert rules before moving to machine learning. One of the things you will learn from our AI course is that machine learning models are often black boxes. For example, we developed a supervised machine learning model that could predict dry gas seal failures in the gas compression system of a North Sea platform with 81% accuracy. 81% accuracy is a great result, but every rotating equipment expert to a person wanted to know why the model made a prediction when it did. What were the underlying conditions hidden in the digital twin that triggered the predicted failure? Now, because of the underlying maths of the model, you simply cannot unpick the decision and explain why. Now, if you have enough well-labelled instances of faults in your equipment, you can use machine learning approaches to build very accurate predictive models. But for that accuracy, you trade off explainability. Now, here is a simplified example of the black box model we built for the gas compression system. It uses real-time data from over 50 sensors that are fed into the digital twin. The predictor model converts the raw data over a 12-hour window into a series of features, and these features are fed into the model once every 30 seconds, and a percentage probability of failure is produced. Now, the model uses a neural network, the inner workings of which cannot be explained to any human. And it will take time for engineers to build trust in black box models. Now, we are working with Strathclyde University on making AI models for oil and gas more explainable. But this is an early stage R&D project, and it will take time to mature. So for now, we recommend that you don't start with black box machine learning models. Instead, start with models based on expert rules that users can intuitively understand, and introduce machine learning at a later stage. Here is an example of an expert rule for predicting and preventing active thrust wear. It calculates in real time a range of conditions that, should they arise, are precursors to probable failure. And like machine learning, the rule uses statistical features based on raw sensor values. In this case, the rate of change and the range of 3 sensors sampled over a 1-hour window. Expert rules have 3 advantages over machine learning. One is that they are quicker and less expensive to implement than machine learning. 2 is that the rules are built using your expert's knowledge of physical systems. This is a collaborative approach that puts your experts and their knowledge at the heart of the system and promotes trust in the technology. And the third reason is that the output is a white box model. Your experts can interrogate a prediction and understand why it has been made based on the sensor values. Now, expert rules are typically less accurate than specialist machine learning models, but they build confidence in the AI with the end users. And right now, trust and confidence in this new technology are more important than building the best model. Lesson 5 is to keep it simple. Users want tools that are powerful but easy to use and understand. Remember the ticking clock at the beginning of this presentation. We have 48 hours to decide if we are going to intervene before failure. And this is common because equipment experts work in high pressure environments. The impact of failure can be very high, with one instance causing millions of dollars in lost production. So you have to keep it simple for end users and not overload them with too much information. And the first generation of PC-based predictive tools are very complex, and they require a lot of training and experience to master. The latest generation are cloud-based, with web interfaces that users can understand and master in hours, not weeks or months. And great predictive maintenance solutions have 3 other things in common. The first is that they are interrupt-driven. They process complex information in real time to make simple recommendations for subject matter experts to review as and when required. The second is that they are explainable. They provide users with collaborative tools to analyse the digital twin to increase the confidence in any decision to intervene. And the third is that they are action oriented. There is no point predicting failure if no one ever intervenes. So great predictive maintenance solutions not only alert, but integrate to other systems, such as maintenance management, to create urgent work orders to investigate and resolve problems before breakdown. So to conclude, we have learned 5 key lessons from our work in oil and gas and other industrial sectors that will increase trust and confidence in predictive maintenance technology. And we believe that earning the trust of equipment experts is the key to unlocking the substantial benefits of increased production recovery, reduced operations and maintenance costs, and reduced CO2 emissions. Thank you very much for your time today.
Thank you very much, John. That was really descriptive, and I like the way you broke it down into those 5 very straightforward points. It's interesting what you said. I think one thing that really resonated with me was the communication and collaboration, because yesterday a lot was talked about the technology, but I think there was a couple of comments made by people saying, look, technology is not going to save us. It's not about technology and that's it. We're going to get out of the woods for everything. It needs communication, it needs collaboration. I think people do lose sight of that. So it's very interesting you mentioned that. So thank you very much for that, John. You mentioned building trust is key to user adoption. Are there any particular challenges in building trust in solutions, particularly based on, let's say, machine learning and digital twins, in your opinion?
Hi Adam, and thanks for the invite. It's good to speak to you and the delegates. Yeah, trust is a word that I use a lot in the presentation. I think, I guess to try and boil it down, I think there's 2 major challenges to building trust. And it's a new technology, and trust is hard enough in any technology, never mind a brand new one. I think the first challenge is to find the value. There was a great breakout session that I joined by the Baringa team yesterday. And there was 2 quotes from that session that stuck in my head. One was that digital twins only exist to deliver a use case. And the second question that was asked was how will the CFO measure the value of the use case? I think getting that value is a big part of the trust, because unless you can find the value and convince the leadership team that there is value, then you won't get off the ground, frankly. I think for predictive maintenance, which is the use case that I'm interested in, I think the value is pretty clear actually, so I don't think that's a major challenge. But you have to make sure that you define it clearly and communicate it with the CFO and the whole leadership team, probably with a cost-benefit model behind it, and then use that, effectively a promise to start to build the trust with the leadership team. So I think that's one of the first challenges, but the second one is the users. I think the users, I know the users are so important to this, and I guess building on the presentation, it's the men and women in the offshore platforms and in the onshore control centres that are faced with these really difficult decisions. They have to trust in the technology. If they don't engage with it, it doesn't matter how good your business case is and what the value you could generate from it. If people don't engage with the technology, learn to trust it, and then learn to make decisions to intervene before failure, then the CFO won't be happy. In fact, nobody will be happy. So I think that whole user engagement is really important in any IT project, as we know and we've all learned in the previous conferences. I think 70% of a project should be spent on the people. But I also think with AI, it's new. There's an element of distrust, I think, sometimes with AI as well. So I think it's even more important that the users are totally bought into the process and we spend the right amount of time with them. So I think that's the two challenges that I see.
Yeah, it's a very good point about the percentages, because I think we mentioned yesterday in one of the panels how it was 80% person, 20% technology, but I think it's sort of around that level people are trying to quote. How do you overcome these challenges though? Because there clearly are a number of them that you mentioned. What lessons can the oil and gas industry learn from that?
Yeah, I think the challenges well, the way to overcome them, there's a lot you can talk about here, but I'll just mention two. In terms of building trust with the leadership team and the CFO, I think it's clarity of the objectives, clarity of the cost benefit case that you're building for it, and having very clear and measurable success criteria. We typically go from pilot to production rollout. And I think at all the stages as you make decisions to start to roll out this technology, you need to say, this is what we thought we would get from it, this is what we got from it, can we make a go, no go decision to move forward? And I think keeping that simple and clear to the leadership team, to me, is really important. And with the users, it's good old-fashioned change management and project best practice, arguably. That's communication. Over-communicate would be my recommendation. Collaboration is the expertise of the end users is at the heart of predictive maintenance, so make sure they're at the heart of your project. I think simplicity, keeping it simple, making the tools as simple and easy to use is going to become really important, especially in these time-poor, high-pressure environments that people are working in. And the final part is explainability. We have a breakout session at 1 o'clock with some of the team from Spartan and Strathclyde, which is all about explainability. But I think as people understand black box, white box, grey box models, you have to put the model and how it behaves alongside the user trust discussion. And that's why in the talk I talked about starting with expert rules, only because they're more explainable, not because they're more accurate. And I think it's about the trade-off between the simplicity and explainability of the technology with the benefits you're trying to achieve has to be balanced very well as well, Adam. So yeah, that's I guess the key lessons I would take to build trust.
Wise words. I think you mentioned Strathclyde. We're very interested about the collaborations with academic institutes in particular. Your team works very closely with Strathclyde University. What do you get from that relationship?
Yeah, it's great because we're based in Glasgow in Scotland, and therefore we have access to some of the world's best research universities, within 30 to 50 miles of our office. But our office is actually co-located on the Strathclyde University campus in the centre of Glasgow. So that makes collaboration even easier. And Strathclyde are a globally recognised centre of excellence for industrial informatics. So when we started building out our Profis product, predictive analytics product, which was about 3 years ago now, we immediately engaged with their computer science and electrical engineering teams. And again, what do we get from that relationship? Well, we get access to cutting edge machine learning research, which is really useful. We get the benefits of Strathclyde's experience in machine learning, which is over 10 years, a very long time in AI, and they've been doing this for lots of industries, including oil and gas, so we can tap that expertise. And probably most importantly, we get a chance to embed the university's experience and research into our product development team. And so we have 2 or 3 people currently from Strathclyde that work full-time or part-time as part of our product team. And that is a really good way, very well proven way to commercialise research. So I think, given that Scotland and the UK has got some great universities, we should really make more of them, in my opinion.